In this module, we look at laminated veneer lumber and plywood. Both of these are engineered wood products manufactured from plies of timber or thin veneers of timber. We're going to look at applications and design methods of both of these. So laminated veneer lumber is made by taking thin plies of timber and gluing them together so that their grain is essentially running in the same direction. By gluing and pressing them together, we can get large pieces of timber much like this, made out of laminates of timber of this kind of size. So these long pieces of timber have got a great deal of strength because they're made from a large number of laminations. Plywood, however, is also made from thin veneers of timber, but these thin veneers are laid up in alternating directions. And that gives a plate element that's generally quite thin, but can carry loads in both directions. So it's got strength in both directions, and it's made into plate elements typical of this one here. So plywood and LVL. Laminated veneer lumber can be designed using AS 1170 Part 1, Section 8. The properties have to be obtained from the manufacturer, and LVL is available in standard sizes. They have standard widths and standard depths of members, up to 1.2 metres high. So some LVL members can be as deep as 1.2 metres. They're effective as bending members or where very high tension and compression forces are required. So laminated veneer lumber with generally higher strength and stiffness than sawn timber is appropriate for those high structural demand applications. Laminated veneer lumber can be used in industrial applications where large spans are required in portal frames or high loads have to be resisted in concrete formwork. Laminated veneer lumber is most commonly used in hidden structural applications. The photo shows it used in a timber-framed roof where it's not going to be seen, and it's the bright blue material you can see in that picture. In the right-hand photo, the laminated veneer lumber is on show where you can see the edge of each laminated veneer lumber member as an architectural feature in that particular building. Laminated veneer lumber is being used more and more architecturally. The left-hand photograph shows it as segmented arches in a band shell. Here, straight pieces of laminated veneer lumber are bolted together, overlapping each other at slightly different orientations to create a smooth curve. In the right-hand photograph, laminated veneer lumber is used both structurally and architecturally on the inside of a building. A prize-winning building in Australia is shown in this particular picture where very substantial loads had to be resisted by the roof of that particular building, and laminated veneer lumber was chosen for its structural capacity but also expressed architecturally in the building. Plywood has a large range of applications from purely decorative panels to structural systems, including flooring, formwork and bracing. It can be also used as webs in portal frames or as connections in trusses. Surface veneer quality is specified according to the application. Where a high level of appearance is required, an A quality veneer would be used for the surfaces, but where it's just used for bracing and not on show, a D level would be used. So plywood is designed using AS 1720 Part 1 in Section 5. In Section 5 is the properties given in Table 5.1, but also design methods. How to design the plywood as plates for out-of-plane loading or panels for in-plane shear loading. It is available in standard sheet sizes, and there's limited thicknesses, with generally the thickest ply being around 20 millimetres. It can be used very effectively as a structural element, but also decoratively. And in this slide are a couple of rather spectacular uses of plywood. As a stair structure on the left in an art gallery, where it itself is a work of art. and in the right-hand photo as part of a pre-primary where it's used both structurally as an element in the roof structure and architecturally as part of the dividers. Plywood can also be used in industrial applications, and here you can see some portal frames and trusses where the plywood is used as gusset plates, carrying extremely high loads as part of the connection system. Plywood decorative panelling can also be used to resist shear forces, and in both of these cases the plywood performs both an architectural and an engineering function. Glues. Again, this relates to the service classes. For service class 3, where the plywood could get wet either in service or during construction, a type A bond should be specified. This is a glue that is appropriate for exterior use plywood. For internal use only, which is service class 1, type C and D bonds could be used. Glue lines can contain treatment, and that's a really effective way of getting treatment into whole sheets of plywood. The structural design of plywood considers two different variants. One is in-plane loading, where the plywood is essentially loaded as a really deep beam. So the loads for in-plane loading would be applied here, and stress is induced in this direction and that direction at the top and bottom of the sheet. Out-of-plane loading loads it very much like a floor. In this case here, the loads are treating the plywood as though it is a miniature slab. Both of them use composite section theory to analyse the plywood, and that is fully detailed in section 5 of AS 1720.1. In specifying plywood, it's important to specify the stress grade. So the stress grade relates to its structural properties. The thickness and number of plies will relate to the section property that can be achieved by each sheet of plywood. The glues are important as well. Is it interior? Is it exterior? Is it a marine grade plywood and hence glue that is required? Quality of the face finish relates to whether it's got a dual architectural and structural role. If it does have an architectural role, it is going to be a quality A finish. And the species used on the face and other plies may be important if it does have an architectural role. So in summary, laminated veneer lumber mainly used in beam applications. They can be quite high beams. They have high strength. They can be used for large structural demand, tension, bending or compression members. It's designed fully using AS 1720.1 and information that comes from the manufacturer. Plywood is for panel applications. Those panel applications can have joint, architectural and structural roles, and again the design methods are outlined in AS 1720.